So we are going to talk about the instant messaging solution that we have, as I mentioned, and I'm going to co-present it with my colleague, Claus. So we have recently rolled out instant messaging in both Android and the iOS app. It happened in the last couple of months, and we have used GRPC and Protobuf extensively in both of the platforms. So if you look at the overview of the presentation, I'll just go over briefly the the product features and how we the basics of gRPC and Protobuf. We will talk a bit on code generation and how you can integrate it. And also, we will be finishing off with, how you can actually accommodate versioning changes in the networking definitions and how you have the interface. So Truecaller IM is quite similar to other instant messaging solutions that you can find in the market. We provide it in Android and iOS. So it supports the basic media types like video, message, location, and contact sharing. At the moment, it's only available as a one-to-one communication platform, but soon we are planning to actually expand it to support group messaging. And one nice feature which actually applies to the Android app is that it brings functionality which is really close to iMessage that we had in iOS for years. So you will be able to actually switch between SMS and instant message. And the color scheme is also quite similar with green and blue. And one other feature that we have over the other instant messaging solutions is to be able to do spam link detection. So as I said, we have a strong user audience, huge growth in the emerging markets, and they sometimes have the problem with fake news. So this is a crowdsourced solution to be able to identify URLs that we have while we are chatting, so that users can know if it's spam URL or not before they actually click on a link. And yeah, and that's mostly it for the IM part. And soon, I think Claus will talk more on the future work that we are planning to do. So I would like to dive into a bit of the technical stack. So we used Protobuf and gRPC, as I mentioned, and both of them were actually technologies that we were using previously for other services, like heavy load services that we had. So this is basically a significant change from the regular HTTP connections that you have in your mobile apps. So instead of using Alamofire or AF networking or similar solutions, this one uses HTTP2, which I will come in shortly. So I would like to start with Protobuf, the model definition language that the gRPC is using. So it's basically a interface definition language. So what you have is actually a tool developed by Google starting from 2001, and then it has become public in 2008. So it's basically a data format and interface definition language, which you can compile into many different languages. So assume I'm defining two objects, like a joke and a comedian. You would have the field types and the field names along with the order of the fields, which helps with serializing and deserializing. And then you would be able to actually convert these objects into the language that you want. So for example, you would be able to convert them into Objective-C, Java, JavaScript, Python, and C++. But there are many other languages that you can use. And you would be able to, like, instead of doing all the JSON serialization, you would be able to, like, serialize them into binary format, which would give you some, like, advantage, like, in terms of overheads that you have, and also, like, it will cut on resources. So at the moment, the project is still, like, maintained by Google, but all are open source. And the Swift support is actually maintained by Apple. So I shared the link down here, and you can go and take a look. Objective-C support is actually maintained by Google at the moment, but both are actually fine to use. So when we started doing IAM, actually, the Swift support was in beta. So we didn't want to actually, like, use it. So we went with Objective-C. But you can safely use the Swift language generation as well. So GRPC is the way to communicate. If we are to say, like, Protobuf objects are the model objects that you are going to actually, like, transmit. GRPC is the networking layer where you define the methods on the endpoint or the backend side, where you can actually, like, call like you are calling a local resource, like something in your local runtime. So it will give you both synchronous and asynchronous, like, communication means. And, like, you would be able to, like, look at all the source code that you have. So the official repository is in GitHub. You can take a look there. And, like, you would be able to actually, like, find other languages, like, which are supported by gRPC. So Protobuf and gRPC, they're supported by multiple languages. And you can use it to, like, define both your client and server architecture in the language that you want. So we use the proto language to define the service, the methods that we have. And assume we have an endpoint like Comedy Central, where we actually fetch our jokes. So you can define it like a remote procedure call, where you have, like, a get joke method, which returns a joke. So it can be called, as I said, synchronous or asynchronous. But the point is to actually to be able to share this, single definition over multiple languages and platforms. So gRPC uses HTTP2 for data transport, which means that it's, like, much more optimized compared to HTTP. And you will be doing your definitions in Protobuf. And the supported languages, which are quite extensive, contains Objective-C and Swift as well. So you can define your, like, client architecture, your client implementation in these two languages, and the backend can support maybe like Node.js or C# or Java. And, like, so HTTP2 is the underlying communication way in gRPC. You can send, like, there are multiple actually, like, enhancements over HTTP, which comes with HTTP2. So with this one, you're able to actually do multiple requests over a single communication channel, which means that you don't have to exchange the headers all the time. You don't have to define, like, which HTTP method that you want to use. And also it supports, like, header compression, which means that if you're not going to change the header in a request, you are able to, like, send it in a much more compressed way. And these are actually all, like, residing on a binary protocol versus, like, compared to the textual HTTP, where you can see, like, this is a get method, it returned 200 or some other error code, and you're able to see all the JSON content. And it actually, like, this has been started as, like, in under another project named like Speedy, and has been also, like, developed by Google. And they're claiming it's providing up to 60% better performance over the regular HTTP. Lastly, I would like to talk about streams, which we didn't have in HTTP. So this basically means that you can keep a channel open to between your backend and your client. So this channel can be unidirectional. It can be bidirectional, meaning that you can send a series of events or you can receive a series of events. I mean, of course, the regular request and response method, it still applies and you can still use it. But this is much more efficient if you want to transmit chunks of data like images or a series of events like we did in instant messaging where we receive a series of messages or reports. So what we do basically is to, once we receive an event, we immediately send back an acknowledgement, setting up a ping-pong type of communication. This acknowledgement means that the client was successful to receive the event and lets the backend know that it can send other events. And this way you can actually ensure the ordering of all the messages, all the data packs. They're fine and you can trust on the ordering. So I'm going to now hand over to my colleague, Claus, who is going to run over some example code and will tell you more about how you can integrate GRPC and Protobuf. So thank you for listening to me.
Is this on? Yeah, it's good. All right, yeah. So what I would like to walk you through is a bit about how we managed to set up using GRPC and Protobuf, in our case with CocoaHeads, and how we have, it's very easy to generate a sample implementation. So just going to switch out of the presentation here for a sec. I'm going to figure out how to do that. Sorry. There, cool, new keyboard. Cool, yes, so this should be readable, good. Yeah, so here's a more extensive example of a Protobuf sample. What we typically do is we have the Protobuf file shared in a submodule with our server teams, because they use the exact same definitions to generate the server side. And here's an example service sort of messaging. It's a simplified version of what we do at Truecaller. We have a standard register call where you register your user, you can think of it as sign in, and a sample send message method. And then just a few more example inputs like user. The more interesting one is the message content, so in our case we have text, we got image, we got video. And actually in the real Truecaller app we have contact cards and location sharing as well. But this is a simplified version. So setting this up in a pod spec is using the Proto compiler plugin, also provided by Google. It's one of the easiest way of integrating it into your project. This runs run the standard Protoc tool, which you can also download separately, including you can download the Protoc Swift one from the link Guven showed you earlier. Generates the output files. So what this will generate is a bunch of rather verbose, hard to read code that you don't necessarily have to care too much about. But the usage of it is very simple. So for example, for a simple register call, the method here, all I do is set up a register request. I call the RPC register, and it will call the register, and then we get a response back. The only thing we have to do is to set up authentication headers as appropriate, if we need those, and start the request. And similar for messaging, what we set up is in this case, we set up the recipient, so the person you want to talk to. And then in the message request, we say, who do you want to talk to? What's the message content? In our case, just text, but this could be image. And the image content, in my Protobuf, I set it up with just the URI, but you could have it as binary blob, you could have thumbnail properties, width, height, the whole 9 yards, as you please. And again, very simple. You just start the request, fire it off. You don't have to do any of the networking part. That's all done for you by the GRPC library. So all retry, all serialization, all of it. It's done for you. This is very convenient. Let's just yeah, and again, so this is a cross-platform solution we use with iOS and Android, and one of the main highlights of this is that rather than dealing with slightly different model objects, like maybe iOS would serialize, like expect yes, no, instead of true, false for deserializing a Boolean. In this case, we don't have to deal with that. It's done for us by library, so you guarantee that you'll have the same module on the server, on the Android client, on the iOS client. So it gives a huge boost to productivity for the teams. Also, when we use APNS for standard push notifications, instead of sending the content there, we send a base 64 encoded version of the GRPC blob, which is a binary, and then we simply just ask the GRPC library, make me an object of the data you just sent me. So once again, we don't have to do any manual deserialization. It's all done for us by the library, which is hugely convenient. And then one of the other really nice features is versioning. So essentially, we can support different type of messages. Once we have a new version of the Proto spec, let's say we have just have video and audio, but then we want to add like voice messages, or we want to add location sharing. We just simply go and add that. And if it's not supported, the version library can allow us to either downgrade, fall back to just the text version only, or we can have like a full version fallback where we decide to say the messaging version you have right now, we had a breaking change, you have to upgrade, otherwise you can't use it. But it's not like we're going to have like an immediate crash because suddenly we deserializing a JSON field to the wrong type. That's not happening because we got versioning, which is somewhat hard to build with the regular JSON. But as with most things, GRPC has some, and Protobuf has some good and some nice things, and some bad things. So again, the goods, it's lightweight, the binary encoded, uses very few resources, both client and server. Shared network platform layer, I believe they all built in all C++, so interface description providers between endpoints, so you don't have to like set up your own like routes as you may do in Alarmify today. No manual serialization, as mentioned a few times now, so a lot less code to write, which is always nice. And again, strongly guarantee the same object model between iOS and client. And I should have added server here as well, because that is a huge benefit. You're not going to have the case where the server team comes and tells you, oh, by the way, we updated the JSON model. Now it's totally different and breaks your app, because that sucks. The bad stuff is that the generate Objective-C code it's not pretty. It's not really pretty when you're into that advanced stuff. Even worse is the lack of proper error handling, which is quite complicated. We get a standard NS error on iOS, which we then have to take the localized description of in order to get a string constant that may or may not mean something. So that's definitely an error we hope they can improve in. And it's incredibly hard to unit test. So with AF networking and Alarmify, etc., you can use like HTTP stubbing. That doesn't really work that well when it's a binary content you're trying to stub out. Now, we did manage to find some evil ways of abusing extensions, among other things, to mock out the types, but I'm not really sure we would recommend that too much to do, but it was a fun exercise. Then yeah, future work for us is to add group support, which hopefully won't be too difficult. And then we're also looking to use this to add end-to-end encryption. And at least the nice part about this is if we do this through the framework, then once we just do updated versioning, we don't have to have Android and iOS doesn't have to go and implement separate encryption support. It should all just work through the framework. And that this is what have been enable us to build an IM client in, well, coming from, I previously worked at Skype, so this was very fast. We built it in like, 6 months or less? And that's, I've never seen it done that fast before. So that was very impressive. So yeah, I think that's it. We have time for a few questions if anyone asks anything.
So maybe we should do like this. If you raise your hand and ask the question, if you can repeat it to our streamers, since we're only having one hand mic.
Absolutely. Okay, so the question was if we would recommend using Protobuf to define like a unified object model and constants. And I think that would be very nice. I'm not 100% sure if it supports it out of the box. And we use Firebase to have configurable variables for most of these things today. So essentially a different endpoint, so we can configure them at runtime. Although I think it's, if it's possible, then I would probably recommend it, yes.
So you can find support for things like enums, like nested structures, static variables. You can find stuff like protection level identifiers, like internal, public, protected, those kind of things. But there is also a bit of overhead because you are not like in Proto2, you can find like optional and required like identifiers. But since everything has to be shared between all the platforms that are supporting it, I would say that there is going to be a minimal, overhead compared to doing everything like manually. But still, I would use it to make sure that the object graph is the same, and you're able to actually serialize and deserialize it into binary data.
And actually, just to add a bit to that, I think once we build group support to add on top of this, that'll be like the ultimate challenge in either proving or disproving that the framework can support building the same feature across two platforms at the same time and extending on it at the same time.